Good day, juniors! Our topic is all about the pH scale. For today's lesson, we are going to calculate pH from hydronium and calculate hydronium and hydroxide of a solution from pH. Calculating the pH of solutions. The pH scale is a log scale that corresponds to the hydrogen ion concentrations of aqueous solutions. Mathematically, pH is the negative logarithm of the hydronium concentration. pH is equal to the log of hydronium. Essentially, the negative powers of 10 in the concentrations are converted to positive numbers. For example, a lemon juice solution with hydronium of 1.0 times 10 to the negative second power m has a pH of 2. This can be calculated using the pH equation. For whole numbers in the hydronium, remember to add the correct number of significant zeros to the resulting pH obtained on your calculator. pH is equal to the negative log of 1.0 times 10 to the negative second power. pH is equal to negative times negative 2, and that will be equal to 2. Let's look at how we determine the number of significant figures in the pH. For a logarithm, the number of decimal places in the pH value is equal to the number of significant figures in the hydronium. The number to the left of the decimal point is the power of 10. Steps for a pH calculation. The pH of a solution is determined using the log key and changing sign. For example, to calculate the pH of a vinegar solution with the hydronium of 2.4 times 10 to the negative third power m, you can use the following steps. Step 1. Enter the hydronium value. Enter 2.0 and press EE or EXP on the calculator. Enter 3 and press positive or negative to change the power to negative 3. For calculators without a change sign key, consult the instructions of the calculator. Step 2. Press the log key. Change the sign. The steps can be combined to give the calculator sequence as follows. pH is equal to the log of 2.4 times 10 to the negative third power equals 2.4, and then you press the EE or EXP, and then 3, positive or negative, and the log, positive or negative. That will give us the answer of 2.619789. Be sure to check the instructions for your calculator. On some calculators, the log key is used first, followed by the concentration. Step 3. Adjust significant figures. In a pH value, the number to the left of the decimal point is an exact number derived from the power of 10. The number of digits to the right of the decimal point is equal to the number of significant figures in the coefficient. Because pH is a log scale, a change of 1 pH unit corresponds to a 10-fold change in hydronium. It is important to note that the pH decreases as the hydronium increases. For example, a solution with a pH of 2 has a hydronium 10 times higher than a solution with a pH of 3 and 100 times higher than a solution with a pH of 4. Sample problem. Calculating pH. Determine the pH for the following solutions. Hydronium is equal to 1.0 times 10 to the negative fifth power m. For the solution, step 1, enter the hydronium using the changing sign key. As I have told you, you need to consult the instructions in the calculator. 1, and then press EE or EXP, and then 5, positive or the negative sign. Step 2, press the log key and change sign key. Log, positive or negative. Step 3, adjust significant figures to the right of the decimal point to equal the number of significant figures in the coefficient. Now let's answer this sample problem. Calculating pH from OH. What is the pH of an ammonia solution with an OH of 3.7 times 10 to the negative third power m? For the solution, you enter the hydronium using the changing sign key. And then after that, you press the log key and change sign key. And then for your final step, adjust the significant figures to the right of the decimal point to equal the number of significant figures in the coefficient. Next is calculating the H3O from the pH. In another type of calculation, we may be given the pH of the solution and asked to determine the hydronium. This is the reverse of the 10x key, which is usually a second function key. On some calculators, this operation is done using the inverse key and the log key. Okay? Sample problem. Calculate H3O of coffee with a pH of 5. For the solution, step 1, enter the pH value and press the change sign key. For the step 2, convert the pH concentration. Press the second function key and then the 10 to the x key. Or press the inverse key and then the log key. Write the display in scientific notation with units of concentration. So the answer is 1.0 times 10 to the negative fifth power m. Step 3, adjust the significant figures in the coefficient. The value of 5 has only one digit to the right of the decimal point, which means the hydronium is written with only one significant figure. So H3O is equal to 1 times 10 to the negative fifth power m. Let's try these practice exercises.